please welcome Sethanne Howard back to the Rockville Science Center. Sethanne, thank you for stepping in this evening. In the past, you have presented for us on black holes, the history of women in science, and asteroids impacting the Earth. Dr. Howard earned her PhD from Georgia State University. Her dissertation explained the now accepted idea behind the appearance of the Whirlpool Galaxy. Sethanne has taught high school physics, university astronomy, and has worked as an oceanographer and meteorologist for the U.S. Navy. At the Navy, she created and conducted an automatic data processing and geophysics training program.
Don't worry about the details, but the first line is the standing stones in Malta, where they recorded the phases of the moon. That's the first known recording of a calendar of sorts in 4000 BCE. But then I want to skip to China. And China it's hidden by the calendars, hidden by the people over here. I want to move the people around. Excuse me a minute. In minus 2159 or 2159 BCE, a solar eclipse occurred. Legend tells us this. China didn't invent writing until 1200 BCE. So they came late into the picture of writing, but they had legends. And the emperor cared mightily about solar eclipses. It was very important. And this solar eclipse occurred and nobody told him. So he dragged the two court astronomers in front of him, Shi and Ho, and they stood up and wobbled, and they'd been partying the night before, and they were drunk as skunks, and they lost their heads. That was the punishment for not telling the emperor that a solar eclipse was about to occur in those days. And then further down, move the people back, the Mayan calendar is, as you know, probably know, a very, very precise calendar. And it started really keeping time around minus 1500. But in the first date, when the Mayan calendar started its cycle, it had cycles and subcycles and sub-subcycles, very complicated calendar. But the first date when it started cycling was minus 3372 BCE. And I have a straight line right there where it is. Well, the Mayan calendar, if you remember 2012, it came to an end. And there were people in 2012 who said, the Mayan calendar is coming to an end. We're all going to die. And those were the pessimists. The optimists said, no, 2012 is the 100th anniversary of the invention of the Oreo cookie. So I think one is better than the other. I don't worry about the fact that the Mayan calendar starts to recycle in 2012. All it means is it starts over again. It's cyclic. And a cycle repeats. Time is all cycles. The calendar is all cycles. That's important. And so there are three main cycles I'm going to talk about tonight. The daily cycle, that's called the diurnal cycle, meaning daily, and that's due to the sun. The monthly cycle, which is the lunar cycle, which is due to the moon. And the yearly cycle, which is the seasonal cycle, which is due to the four seasons, summer, fall, winter, spring. So let's start with the diurnal cycle and see what it tells us. Whenever you look at a diagram that's going to rotate or turn in astronomy, remember always to go counterclockwise. If you go counterclockwise, you'll end up doing the right thing, getting the right answer. So you see the Earth there going counterclockwise around itself. So diurnal means daily, and we cycle through daily Earth rotations, and the Earth is turning 15 degrees per hour. That means in 24 hours, you've turned 15 times 24 degrees or 360 degrees. That's a full circle once around. That's how come we know we're moving 15 degrees per hour as we move around. It turns out if you're at the equator, you're moving over 1,000 miles a second, 1,000 miles an hour. You are actually doing that. Now it changes with your latitude, but at the equator, you're going in the fastest. One full rotation is called one solar day. The sun is driving it. And so it's the time from the solar transit overhead to the next solar transit overhead. That's the solar day. The Earth's diurnal rotation keeps time. The Earth is in charge, not your clocks, not your wristwatches, not your alarm clock. It's the Earth is in charge. And that's important to know because the Earth wobbles, the Earth wiggles, it sometimes goes fast, it sometimes goes slow. And so the time is constantly moving around. And your clock may be keeping beautiful time with respect to itself, but the time that the Earth keeps is not your wristwatch. All clocks are just interpolating devices. So that's important to remember. You can track the sun as simple as putting a stick in the ground. The left-hand picture shows you an ancient Egyptian plate with a hole for the stick. The stick is missing, but they have the plate. And you see the markings that mark out the hours of the day. On the right of the picture, you see a modern gnome. It's called a gnomon, the stick, meaning he who examines, she who knows, one who knows. One who examines. And you see the shadow, and the gnomon in this case is a triangle, but that's because when you're building a sundial, a modern sundial, you need to know more things than just the sundial. There's a supersized gnomon. Maybe those of you who've been to India have been to Jaipur, India. This is a UNESCO World Heritage Site. And these things are supersized. If you look down here, if you can see my arrow, those are high enough that people can pass under them. That'll give you a sense of the scale of this thing. It's huge. They could keep time precisely with this. You're going to need your latitude. So how do you find your latitude? That's easy. You sight on Polaris, the pole star. You get a protractor out there and sight on Polaris and measure the angle up from the horizon, from the ground, and that angle is your latitude. So your latitude is fairly easy to come across. You can also do it with the sun, but it's trickier. It's easier to do it with Polaris at night, assuming you can see Polaris, and everybody in the Northern Hemisphere can see Polaris, not the Southern Hemisphere, but the Northern Hemisphere. So if you're going to build a sundial, you're going to put the gnomon, the stick, angled at your latitude and point it north at the North Celestial Pole or Polaris. You're going to put, that's how you build a proper sundial. And then you mark the hours around the sundial in 15 degrees intervals. That's an hour. And the shortest shadow that it casts during the day is the time of noon. That's the solar transit, is when the shadow is shortest. You can do this with a group of kids. It's wonderful to do it with a group of kids. They get really amazed at watching the shadow change. Today, we don't use the sundial shadow so much. We use the altitude of the sun. You have to know more than just the latitude, but we do know more. So you determine the highest point that the sun reaches during the day, and that's noon. That's the solar transit for the next time it does that. Only that's a little tough because the sun is bright. It's also an extended body. So where do you put its middle? And so actually what people do is use a double altitude method, and they use the east and west equally and then cut it in half. And when you cut it in half, you're doing noon. So that's how you do it with the sun, finding your latitude. Clocks. If you didn't know it, sundials are good to about 20 minutes, plus or minus 20 minutes a day. A pendulum clock, if you can see the pendulum clock over on the right, it's good to about 1 minute a day if it's not so good, or down to 10 seconds a day if it's a really good pendulum. But 10 seconds is not good enough to put it aboard ship, which is why longitude became, or a clock that would ride on a rocking ship became so important. If you've read the book Sobel by called Longitude, and you need better than 10 seconds per day. And just to give you an idea of what that means, I calculated the error that 10 seconds a day would give you. In the 1700s, the longitude east-west length of the Mediterranean was an error by over 1,000 miles. They didn't even know that well. But nowadays, at sea level, 1 arc minute is 1/60th of a degree. There are 360 degrees in a circle. Each degree has 60 minutes. We blame the Sumerians for this. They invented the base 60 math system. And 1 arc minute, we call it an arc minute if it's 1/60th of a degree, along a meridian going like this equals 1 nautical mile. That's the definition of a nautical mile. And it's a little bit bigger than a regular mile. Some of you may know this already, but I'm repeating it just in case you don't. 1 arc second is 1/60th of an arc minute, 60 seconds per minute. So if you calculate what 1 arc second is, it's about 30 meters. So 15 arc seconds, which is what you get with a 10-second, is 1 second of time, and 10 seconds error is 15 times 10, or 150 arc seconds error. And that is 150 arc seconds times 30 meters, or 4.5 kilometer error, just 10 seconds alone. So that wasn't good enough for the ships in the 1800s. They needed their clocks to give them better than 10 seconds error. Okay, we've done the diurnal cycle, the lunar cycle. if you have questions, go ahead and ask them immediately, and we'll answer them if we can. I'll answer them if I can, in real time. But the lunar cycle, unfortunately, on the right, is what appears in all astronomy textbooks. It's a terrible way to describe the phases of the moon. Students find it very confusing. The easiest way to do this is to have somebody be the sun, somebody be the earth, and somebody be the moon. And everybody goes counterclockwise, and that will show you how the phases occur as you move around the earth. That's the easiest way to learn about phases of the moon. And the lunar cycle is new moon to new moon. That's the lunar cycle. The lunar cycle was announced. The tribal scientists in ancient days announced each new moon because they saw it visually. And they were called, the group of them were called a synod. Just like a synod of bishops, the synod started before then as the group of tribal scientists who announced each new moon. It's from the Greek, and it means one who knows. And if you've taken astronomy in school, they threw at you a synodic month, probably without telling you where the synodic month came from. And it's new moon to new moon, but the synod is the one who announced the new moon. So that's where the synodic month comes from. So one cycle through the phases of the moon is called a synodic month. It has 29.531 days. That's one synodic month. You notice it's not an equal number of days. It's off. So it comes close to 29 days, but not quite. Now we have the day and the month. Now let's do the seasons. We cycle through summer, fall, winter, spring, and that's called the tropical year. Tropic means turning of the seasons. Now, I put this diagram up here to show you what a lot of people make a mistake with. You see the line that shows you the axis of the earth here? It's the same here, pointing the same way, and the same way here. It does not flop back and forth, which is a misconception that a lot of people have, that the earth does this flip-flop as it goes from winter to summer. The earth always points in the same direction at Polaris, the North Celestial Pole. That's why I have the picture up there, to show you that it doesn't flip-flop. So summer, fall, winter, spring, the earth is moving about 30 kilometers a second around the sun. That's how fast it's going. And a tropical year means turning of the seasons. Tropic. It defines the yearly calendar. A tropical year is that number of days. It's not exact 365. It's a whole bunch of digits after that. And it's not even 25. That's a different year. The tropic year is the seasonal year, the one that goes summer, fall, winter, spring. And it's not an exact number of months or an exact number of days. But it's got 4 seasonal markers: 2 solstice, summer and winter, and 2 equinox, spring and fall. Those are 4 markers that divide the year into quarters. Solstice means sun standing still between the stones. Here are the stones marking out the calendar, and the sun rises between the stones. And that's standing still between the stones means that day after day after day, it rises in that position. So at that time of year of a solstice, the Earth is moving the slowest in its orbit. So it takes it a long time to move off from between the two stones, hence Stonehenge. So sol for sun and stish for interstitial. The rising sun falls between the two stones that mark the calendar and does that for a long time. There are 2 solstices per year, summer and winter. That's the longest day of the year and the shortest day of the year. Next year, Thursday, June 20th, 2024, at 4:50 p.m. is the summer solstice, if you're curious. Saturday, December 21st, 2024, at 4:19 a.m., it's the winter solstice. And if you're really curious, it's going to occur in 2 days. Thursday, December 21st, 2023, at 10:27 p.m. If you're going to have a party, and I think everybody should celebrate the solstice. So have a party on Thursday. The equinox means equal nights. And the equinox is when the number of daylight hours equals the number of nighttime hours, or they're 2 per year, spring and fall. And next year it will be Tuesday, March 19, 2024 at 11:06 p.m. spring equinox. That's the spring equinox, which is important for dating certain religious festivals. Sunday, September 22nd, 2024, 8:43 a.m. is the fall equinox. So there they are. There are 4 of them, 2 solstice, 2 equinox. And then suppose you have a solstice and an equinox, and you have halfway in between. Those are called cross-quarter days. The solstice and the equinox are called quarter days because they divide the year into quarters. Cross-quarter days divide the year into 8. And it's halfway between the solstice and the equinox. And it turns out that those are religious festivals, ancient religious festivals. May 1st, May Day, when they danced around the maypole. August 1st is Lammas Day. November 1st is All Souls Day. And February 2nd is Groundhog's Day in the United States. So those are cross-quarter days, and that gives you 8 days a year to have holidays on, religious holidays. And they did. That's a groundhog popping up, if you can see it on the right, popping in and out and seeing his shadow and getting scared and going back under. And there's a small picture of people dancing around a maypole on the left. But most people don't know what a cross-quarter day is. I think they're a lot of fun. If you can get them at a drinking party with cross-quarter days. Now, it's very unlucky that the moon cycles in 4 7-day weeks almost. 12 synodic months are very close to the tropic year, almost. And it's just an unlucky accident that this occurred. Coincidence. It was unfortunate because early civilizations tried their hardest to devise calendars that tried to reconcile the lunar synodic month with 12 lunar months to the solar year of 365 days. A lunar month is 354 days. A lunar year is 354 days. So they tried awfully hard on all kinds of different ways to make these two add up. And nobody did it well. Now, this was job security for the astronomers because you needed astronomers to tell you when this stuff occurred. And defining the calendar was the main duty of ancient astronomers. And it was important, more important for taxes. You think it'd be important for the agriculture, growing things, but it was more important for taxes because we have records. The earliest text records we've got on cuneiform tablets are goods received by temples or tax documents. In other words, what has the temple received to pay the taxes? The temple needed a calendar to know when to collect the tax, and taxes were paid by cows and sheep or merchant goods. And it was not minor. Almost 37,000 sheep were delivered to the temple in 1 year in northern Palestine. That's a lot of sheep. And Hammurabi, the one who did the code of laws that are so famous, he wasn't the first one to do it, but he's the famous one. And he got mad. He said, the year is out of place. Straighten it out. Change the tax date from this month to the next month and drop the month. In other words, astronomers, get with the program and clean up the calendar. I need my taxes. They had to straighten out the calendar because once you tried to match up a synodic year with a solar year, everybody did it differently and it never worked. So what cycles do we use for a calendar? We use a synodic month, which is a bit more than a 4-7-day week, and a tropical year. And there's the length of the tropical year is the average interval between spring equinoxes. We're coming to the calendar part of the talk. Calendar comes from the Latin calare, meaning proclaim, which is an indication that they proclaim the new moon. The priests of the ancient Latins, the ancient Romans, would proclaim the new moon. And the calend of each month is a remnant of the importance of each new moon. The calend is the beginning of the month. So a synodic month, we've done that. Did I go backwards?
Yes.
I did. Yes, a lunar year is 12 synodic months, or 354 approximately days, and a solar year is approximately 365 days, and a lunisolar year is when you try to combine them and try to make a solar year using lunar months. Well, everybody had a different way of doing this. And then you had the problem of when does the year start? Everybody had their own New Year's Day. You see there a bunch of different possible New Year's days that we know of, and it could be the day the taxes were due. That was the New Year. So every city-state had its own New Year's Day. Bear that in mind. If you're going to write a contract for your city-state to be effective in another city-state, and you don't know when its New Year's Day is, how can you put the dates in your contract? The solar calendar was started in ancient Egypt. And I like their calendar. I wish we did this. They had 360 days with 5 leftover days. They had 12 30-day months. So what do you do if you have 5 leftover days at the end of the year? You party. And that's what the ancient Egyptians did. They partied for 5 days. I think that's wonderful. I think our calendar ought to do that, but we don't. The New Year's Day was the day that the star Solstice, they called it, but it was the star Sirius, rose with the sun. That was New Year's Day. They knew when it started, but there were 5 leftover days, and they partied for 5 days. Very civilized. There are 3 types of calendars that I've talked about. I've talked about a solar calendar, which keeps synchrony with the tropical year. And bear in mind, there's no year 0 in a solar year, in a solar calendar. The calendar depends on the Earth's orbit, and this is the calendar that's used worldwide by international treaty. The lunar calendar follows the lunar cycle, not paying any attention at all to the tropical cycle. And the calendar depends only on the phases of the moon, and it has 354 days per year. So somebody who has a lunar year is Islam, and their year is a lunar year. And so that's why the holy month of Ramadan shifts each year in our year, in the solar year, because they're counting on 354 days for their year. A lunisolar calendar combines them, and every few years they stick in a month to make the months come out even at the end. Here's the Islamic calendar. And after 3 years, it shifted a whole month out of sequence with where it started in our years.
Could you go back to the slide that had the 3 different kinds of calendars for a moment?
This one?
Yes. Okay, now you can go on. Thank you.
Okay. Lunisolar calendars. People really worried about these, but this is one that tries to reconcile them. Some people don't. China and India, for example, use a lunisolar calendar for holidays. In the 5th century BCE, a Greek by the name of Meton set down the rules for inserting the extra months to make the lunar year stretch to the tropical year. These are the rules. Start counting your years with a year that starts on a new moon. That's year 1. 19 years later, this will occur again. It takes 19 years to cycle through until you start again with the year starting on a new moon. The Metonic cycle is 19 years, and it was considered to be so important once they discovered this 19-year cycle, and everybody knew about it. The Sumerians knew about it. The Babylonians knew about it. The Egyptians knew about it. He just was the one who set it down in writing. Insert extra months in a preset pattern, and every 19 years, repeat the preset pattern. The golden number tells you where you are in the cycle, 1 to 19. And it's called the golden number because the Greeks thought it was so important that they engraved the number of the 19 cycles in gold on their chief temple in Athens. And that's why it's called the golden number. And the golden number is important in setting calendars. And we use it today still in setting the date of Easter. Well, the lunisolar calendars, the Romans entered the picture. The Romans did it all wrong. They had 10 months in a year, Novem, 9, Decem, 10, December, November, 9, October, 8, October. They had 10 months in the year, and they just randomly threw months around. They didn't pay attention. And basically, by the time of 56 BCE, it was 80 days out of sync with the seasons. So the Romans had messed it up mightily. So along came Julius Caesar. And Julius Caesar borrowed an astronomer, Sosigenes, from Cleopatra. And he established for Julius Caesar a solar calendar. And that's the Julian calendar, which you probably have heard of before. Julius Caesar said he moved New Year's Day to January 1st because it was March to the Romans. They scattered holidays through the years. They created 7 31-day months, 4 30-day months, and 1 28-day month. They added an extra day, and it was an extra day 6 before the March calend. It was the 6th day before the March calend, which was the beginning of March. That's why bisextile year is the official name for a leap year. It's got an official name. And they started doing this in about 46 BCE. And to clean it all up and start it all again, they had a year of 445 days. Well, then, of course, we know what happened to Julius Caesar. We lost him. And Caesar Augustus came into power, and his team, his synod of astronomers, messed it all up again. They didn't insert the months. They didn't keep the months lined up. Caesar Augustus got really annoyed. So what he said is that from 8 BCE to 8 CE, 8, 9, 10, 11, 12 years, we're not going to stick in any extra months. There's nothing going to happen. Everybody's going to stop counting. So he renamed the 6th month, which was Sextilis, to August. That's where August got its name. And the Julian calendar then operated from 8 CE to 1582 CE. That's when the Julian calendar operated. This one, you know. And it became the Christian calendar by the Council of Nicaea. But there was problems with the Julian calendar. The biggest problem was finance. Every city-state had its own New Year's Day. So if you need to go from Venice to Paris with your contract, your financial contract, you're going to leave Venice in 1245, travel to Florence, arrive in 1244, go on to Pisa and arrive in 1246, and then on to cross the border into France in 1245 and get to Paris in 1244, which is before you left Venice. This is going to make it tough to fulfill a commercial contract. Really tough. So people were complaining. the economists and the people who wrote contracts, the business people, were complaining about this all the time. And then, in addition, Easter kept slipping. By the 16th century, the Julian calendar had slipped the spring equinox from March 21st to March 11. Now, here are the rules for Easter, in case you didn't know. The full moon preceding Easter was not to precede the vernal equinox. Easter is the Sunday following the Paschal or Lamb or Easter full moon on a lunar calendar. That's important. It's not the solar calendar, it's the lunar calendar. The Paschal or Easter month is the first one in the year to have its 14th day, which is its formal full moon, on or after 21 March. Easter is the Sunday after its 14th day. Those are the rules for setting Easter. So you need a lunar calendar, a solar calendar, the golden number. You need a whole bunch of different tables. They did it by tables in those days. They had a whole bunch of different tables for figuring out when Easter occurred. And Easter was important to people in the Western world, most people. And the problem of Easter, the canonical Easter tables were actually set in the 3rd century when the vernal equinox did fall on 20 or 21 March. But you needed to compute the future times, and every city-state had a different method for doing this. Every city-state had a different method for calculating when the next full moon was going to occur. Dennis the Little was the one who came up with a set of Easter dates and he was the first one who used AD, Anno Domini. The AD name came from the tables of Dennis the Little, a monk in Serbia, I think, in that area of the world. The AD method caught on since we now use AD in the Christian religion consistently. And computing the date of Easter remains a complicated mixture of several calendars. And in the US, the official date for Easter is given by the US Nautical Almanac Office. And the official date for the, I think, Passover is also given by the Nautical Almanac Office. And the official date for Ramadan is also given by the Nautical Almanac Office. They don't have to follow it, but that's the official date according to the federal code.
Wow.
I was chief of the Nautical Almanac Office. That's how come I know this. I had to calculate Easter and Jewish New Year, and Jewish New Year is a bear to calculate. Well, the Gregorian calendar came next, and Pope Gregory decided to straighten out because Easter was slipping, and it had slipped 10 days by then, and he dropped the 10 days between October 4th and October 15th. You see the calendar in the upper right goes 1, 2, 3, 4, 15. And October the 5th became October the 15th. Days of the week didn't change. And he started his calendar and here's the rule. Every year is exactly divisible, that is exactly divisible by 4 is a leap year, except for years that are exactly divisible by 100, except for the centennial years that are exactly divisible by 400. They're still leap years. That's the complicated little correction he put in the system for calculating when leap years occur. The average Gregorian calendar is that's its length in days. And it's half a minute of the length of the tropical year. So it's very close. And it's only going to get off after 3,000 years before it's as much as one day off. So this whole protocol change was strictly to clear up the date for Easter and to clear up finances. Now, it was the Gregorian calendar, but Eastern Orthodox people did not adopt the Roman Catholic calendar. They weren't about to do that. And Protestant countries did not want to adopt the Roman Catholic calendar. So in the Western world, the Protestant countries kept going with the Julian calendar. After the Catholic countries had started doing the Gregorian calendar, the days kept slipping. Protestant Easter fell further out of sync, and Britain adopted the Gregorian calendar by the British Calendar Act. It went through the British Parliament in one day, the fastest act ever to go through the British Parliament. In one day, they declared the day after Wednesday, the 2nd of September, to be Thursday, the 14th of September, 1752. And it was the shortest September in history. And people who were landlords wanted their rent for the whole month. And the tenants said, we weren't there for the whole month. We lost these days in between 2 and 14. You can't charge us. So the people in Boston rioted over this, the tenants and the landlords. And we're going to end pretty much here. This is out of date, but I put it up because it shows the color code. Green means the country has adopted the Gregorian calendar for just about everything. We don't use it for our religious holidays, but we do for everything else. And blue is a combination of a Gregorian calendar slightly skewed. And orange is, they use the Gregorian calendar and the lunar calendar side by side. The lunar calendar to set their religious holidays and the Gregorian calendar to have contracts with the outside world. Red means they never accepted the Gregorian calendar. Now, this was, I said, is out of date. In 1919, the map looks like this, and the change has been Saudi Arabia. It has accepted the Gregorian calendar as of 1919. Washington's birthday. Now, if you really think you know his birthday, George Washington was born on February 22nd, 1732. That's according to the Gregorian calendar, but the British Empire wasn't on the Gregorian calendar at that time. It was on the Julian calendar. And the British Civil Year began on 25 March, not 1 January. So in 1752, that's when the British Empire switched. And so Americans born prior to 1752 typically have their birthdays recognized according to the Gregorian calendar. But George Washington actually was born on February 11th, 1731, because it was the year before. That was his actual birth date. And I'll end here. We're not at fault. We didn't do this. Congress did this. The daylight savings time came from Congress. So you see them struggling to move Stonehenge around. Well, it's a lot of work for some people to go from daylight savings times back and forth, but it's not the astronomers who did that. So thank you.
And before I bring people in, thank you for supporting us through the year. And actually, we're in our 14th year. We're going to be in our
Oh,
15th year.
wow.
So thank all of you that have supported the Science Center, our lecture series.